Okay, so today we're gonna do only chapter 3. We only do small part of chapter 3 because when I finish this part, I don't think we have enough questions to do other parts as well. So for those who don't know me, my name is Wilting. I'm one of the teacher from TTC. I'm a bio teacher here because I see a lot of names that I don't know. So my name is Wilting, the one that you got your notes. That is me. Okay, it's the same person. Okay, now the reason why I choose chapter 3 is because that chapter 3 is actually a foundation. The reason I didn't do chapter 2, because chapter 2 I've taught it before. If you want to see the entire full video of chapter 2, you can go to my YouTube channel. Just watch the entire video. So, and some of my students think that chapter 2 is too easy. It's just labeling function, nothing much to learn. So I'm going to teach you something harder today, which is 3.2 and 3.3. It's not it's complete. The YouTube video is complete chapter 2, guys. It's a complete one, but I didn't include a lot of questions, but it's a complete chapter 2. Okay, so let's start the class right now. We're going to learn about passive and active transport. For 3.1 is about phospholipid bilayer and the fluid mosaic model. That is also in my YouTube channel. You can also watch that because that part is more on label structure as well. So today I will teach you an answering technique that I never teach before in my YouTube channel at least. In my class, of course, I teach before, but not in the videos. Okay, so what is a passive? What is an active transport? To remember this thing very easily, remember a passive is you do it by yourself. Okay, so passive is somebody do it for you. No energy is needed. Okay, remember passive, somebody do it for you. Actively, right? You do it by yourself actively, so it means it requires energy. So starting from passive transport first, since I say, right, somebody do it for you, passive transport does not require energy. It's without the use of energy. No need energy, things move down the concentration gradient. What does down means? Down means you move from high to low concentration gradient. High to low concentration gradient, to understand it in an easier way, is more to less. But we cannot say more to less. We have to say high to low concentration gradient. Things will always move from more water to lesser water, more carbon dioxide to lesser carbon dioxide, more oxygen to lesser oxygen. This is high to low. So in exam, you can choose high concentration gradient to low concentration gradient, or you can just choose to use down the concentration gradient, or you can choose the word along or follow the concentration gradient. Why water is called water potential, it's not water concentration. This is a very specific word that we use it in biology. For water, we have to use water potential. For gases, we have to use partial pressure. So only certain word we can use the certain specific word. Not every word we can use concentration. Just use water potential, and there's the word for gases called partial pressure. But the meaning is the same, it's just called concentration. Okay, what is the purpose of undergoing passive transport? Is to occur, is to make sure that you have dynamic equilibrium. What does dynamic equilibrium means? It means same. It means balance. Everything has to be fair. It's called dynamic equilibrium. Means more water has to be more water has to be with more sugar. Less water has to be less sugar. So everything has to be equal. It's called dynamic equilibrium. I will show you a thing that what is a dynamic equilibrium later on. So when you write water concentration, do they deduct mark? Some teacher, they will deduct your mark because you're not writing a specific keyword. So to write a specific word for water, you're going to write water potential. Okay, now in passive transport, we have three processes: simple diffusion, osmosis, and facilitated diffusion. Everything here is under passive transport. Everything here move from high to low concentration gradient. To move across your plasma membrane, we have to move through a few places. Number one, we have a thing called phospholipid bilayer. What is a phospholipid bilayer? Bi means how many layer, guys? Bi means how many layer? 2 layer, correct? Bi means 2 layer. Phospholipid, the word phosphor actually comes from the head because the head has a name called polar phosphate head. The head has a name called polar phosphate head. The tail has a name called non-polar fatty acid tail. Non-polar fatty acid tail. So the word phosphor comes from the word phosphate. The word lipid comes from the word fatty acid. So it's called phospholipid bilayer. So always start from the head first. The tail is after, so it's phospholipid bilayer. In your simple diffusion, they only uses phospholipid bilayer. So everything here passes through phospholipid bilayer. We have three different types of example over here. We have lipid-soluble substances, dissolved gases, and small molecule. The example of lipid-soluble, we have fatty acid, glycerol, vitamin A, D, E, K. We also have steroid. What is the difference between number one and the dot? When you see 1, 2, 3 here, the 1, 2, 3 is referring to your characteristic. This is the characteristic. Okay, the dot, dot, dot referring to example. So we have to read the question. If the question asks you to write example, for example, let's say they are trying to ask you, write an example they are able to diffuse across the phospholipid bilayer, and they ask you to explain why. Let's say your example is fatty acid. Your explain why will be because they are lipid-soluble substances. Okay, if your example is oxygen, your explain why will be because they are dissolved gases. If your example is water, your explain why will be because they are small molecule. So the 1, 2, 3 is for you to explain based on your example given. So whenever you choose example, choose 2 examples that are in the same category. So when you write fatty acid, write with glycerol or vitamin A, D, E, K. Then you can write lipid-soluble substances, right? So don't choose fatty acid and glycerol. Sorry, don't choose fatty acid and oxygen because you have no explanation that you can give. So you're going to write fatty acid, you're going to write dissolved gases over here. You have no answer, right? So write them in a pair. So when you write oxygen, you're going to write carbon dioxide. Gases can only be these 2 gases, which is oxygen and carbon dioxide. So more oxygen to lesser oxygen, more carbon dioxide to lesser carbon dioxide. So remember, choose them in a pair. All of these, they will use simple diffusion, move across the phospholipid bilayer. Okay, if it's osmosis, it's even easier. Osmosis, there's only water. No other example besides water. They will pass through 2 places for phospholipid bilayer and channel protein. As a channel protein, it has to be always open over here. This is a channel protein. They always open in the middle. We call this as channel protein. How do we differentiate whether they are channel protein or whether they are carrier protein? As a channel protein, because they are always open, right? As a carrier protein, they only open one part. Can you see they only open one part? Either they open one part or they close the entire thing. Either they only open one part or they close the entire thing. We call this as a carrier protein. So this is how we differentiate whether they are channel protein or carrier protein. So you can see from the diagram itself. So they'll move through channel protein or the phospholipid bilayer, right? Since I say, right, osmosis, we only have water molecule. They always ask you, based on these 2 diagrams, they will give you a YouTube. Okay, this is a YouTube. In the YouTube, we have sucrose inside. We have water molecule inside. They will give you the label, sucrose and water molecule. In middle, we have a thing called selectively permeable membrane. What does selectively permeable membrane means? It means it only allows certain substances to pass through, okay? Only certain substances. Certain means what? Only small molecule can pass through. Based on sucrose and water molecule, which one is smaller to you? From the diagram, as you can see, sucrose and water. Of course, water is smaller, right? Because the size you can see, sucrose is bigger, water is smaller. Water is smaller, so only water can diffuse across the selectively permeable membrane. Can you call it as a semi-permeable membrane? Because in your textbook, they only write selectively permeable. So if you're a teacher who always follow textbook, we have to follow textbook answer. If your teacher is the one who always like die only follow textbook, right? We only follow textbook. So textbook only write selectively permeable membrane. We write selectively permeable membrane. Okay, so only small thing can diffuse across, which is water. Okay, we're gonna count the sucrose right now. We have A side and B side. So A, how many sucrose in total? Okay, let's count together, yeah? 1, 2, 3, 4, 5, 6. 6 over here, right? Can you count on B side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 in total. So 6 and 13. So on A side, we have 6 sugar. B side, we have 13 sugar. Based on the taste, okay, imagine that this is a Milo powder lah. A and B side, which one is sweeter to you? Which one do you think is sweeter, A or B side? B is sweeter, right? Because got more sugar, right? B is sweeter. So since we say that sucrose cannot diffuse across, only water can. In osmosis, it means more water to lesser water. Do you think that the water will move from A to B or B to A? What is the difference between partially permeable and selectively permeable? It's the same. Partially permeable, selectively permeable, semi-permeable is the same thing. It's the same meaning. Do you think that the water will move from A to B or B to A based on what you understand in osmosis? Correct. The water always moves from more to less, which is A to B. So when you draw your result, which is an exam question, you have to make sure that your water on B side is higher. A side is lower. Lower, higher. This is something that you have to take note. Yeah? When you draw the water level, it has to be lower and higher. But the sucrose has to remain the same. A side, we have 1, 2, 3, 4, 5, 6, right? It's still 6. B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? it is still 13. So can you see the number of sucrose never change? The teacher will also count when you draw it, guys. So remember to count the number of sucrose when you draw a result. So remember, to draw, the water molecule is different, but the number of sucrose is the same. Sometimes they don't give you a U-tube, they give you a beaker. And this is the beaker. Same thing, we have A side and B side over here, A and B side. So we're going to count the number of sucrose also, yeah? In A side, 1, 2, 3, 4, 5, 6, 7. We have 7 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 21 in total. So over here, when you draw a result, remember only water diffuses across the semi-permeable membrane. So the water will move from A to B or B to A. A to B or B to A, the water will move from. Correct, it's still same, it's still A to B because the water will always move from more to less. So when you draw your result, B side is always higher, A is always lesser. So only water can diffuse across. You know what people usually make mistake as? They will add the number of sucrose together, they divide 2. So when you divide 2, right, your answer is wrong because it will never be the same. So you cannot like 14, 14 here. Because if it's 14, 14, it means that you never proved that the selectively permeable membrane did not allow the sucrose to pass through. So you defeat the purpose of drawing 14, 14. So remember to count the number of sucrose and to draw only increasing in water level. This is what we call as dynamic equilibrium. Dynamic equilibrium means less water has to match with less sugar. More water has to match with more sugar. It's called dynamic equilibrium. Okay, less water, less sugar, more sugar. Yeah? This is what we call as dynamic equilibrium. The drawing question is one of the questions that you will see in your exam. This is your osmosis. Okay, anybody has question about osmosis and simple diffusion? Okay with this? Can? Okay, now next part, we have facilitated diffusion. Facilitated diffusion is a different one among the 3 processes. Do we have to draw the water dots out? Yes, you have to draw the water dot, but don't have to count the water dot. Just draw the smaller one. When you draw, just draw dot, smaller dot when you draw the water. Facilitated diffusion, they only uses 2 protein. They only uses carrier protein and also channel protein. Only carrier and channel protein. As a carrier protein, as I mentioned, they only open one part, one particular part. They only open one part. This carrier protein, it allows substances to march through. What are the things that they pass through? Only allow large molecule. In large molecule, we only have glucose and amino acids. So again, when do we write the large molecule? Only when you explain your answer. So if your answer is glucose, then you explain why it will be large molecule. For every carrier protein, we have an active site. Can you see over here? This part, we have active site. So they have to match with the active site. Sometimes they will also write as a binding site. Or sometimes they will write specific site lah. So only the correct shape, only the correct pattern can bind to the active site. It's like a puzzle. The part that matches, you have to fit with it. So we call it active site. So they open, close, open, close, open, close. So they don't open the entire thing. They only open one part. Okay, like that, open, close, open, close. Or they will just close the entire thing as a carrier protein. As a channel protein, they open the entire thing here. What passes through the channel protein, which is the charged ion? Sodium, potassium, calcium, whatever charged ion can be under this category as a charged ion lah. Any example that you want to write also can. Usually we will write carrier protein, or we will write sodium ion and potassium ion. Again, how do I know which one here is higher to lower? We can count the number of ions. Okay, the one in red color, yeah. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 over here. At the bottom, 1, 2, 3, 4, 5. 5 in total, right? So since it's more to less, it has to be in this direction, right? More to less, more to less, right? Can you see the arrow is moving in this direction? It's more to less. If you count the one in yellow color, it's the same. 1, 2, 2, 1. So you count it, again, it's more to less. Everything here is more to less because it's higher to lower concentration gradient. This is what we call as passive transport. So in facilitated diffusion, we have carrier protein, we have channel protein. Only in facilitated, we have to use carrier protein. The rest of the process here got no carrier protein. Only this one has a carrier protein. Odd number, how? Odd number doesn't matter what? As long as it's more to less. As long as it's not the same. So it doesn't matter over here. It's just more to less. Because there will be ions coming in. This is not the only one. So just count more to less can already. Okay, anybody has question about passive transport? All good with passive transport, guys? Okay. Okay, now question, we're going to move to the next part. We're going to move to active transport. Active transport is opposite than passive transport. Since passive, no energy is needed. Active, energy is needed in the form of ATP. ATP stands for adenosine triphosphate. Tri means 3 in total. So most students ask, can you write ATP in exam? If your first term exam, your teacher wants you to write adenosine triphosphate, you have to write adenosine triphosphate only for your first exam. Midterm onwards, don't have to write adenosine triphosphate. Phosphate is an ion, actually, it's called phosphate ion. So this adenosine triphosphate, only for your first term exam, you have to write full name. For midterm onward, even in SPM, you can just write ATP, don't have to write the full name. It's very depending on your school teacher, actually, for your first term exam. If your first term exam, teacher allowed you to write ATP, you can just write ATP with no problem. If your teacher allowed you to write DNA, you can also just write DNA. So you can just ask your teacher whether your first term exam, is it okay for you to write ATP or DNA? Okay, something like that lah. You have to ask the teacher. It's very depending on your school teacher. Every teacher says different thing in first exam. So you're going to ask your teacher. So in active transport, we have to move against the concentration gradient. What does against mean? Against means low to high concentration gradient. Low to high means less to more. Everything they will learn less to more. It's called against concentration gradient. In active transport, they will use only carrier protein. Only carrier protein. So means there will be no phospholipid bilayer, there will be no China protein, only carrier protein. The purpose of doing this is to accumulate or to eliminate substances. Accumulate or eliminate means you want to store or you want to make sure that you remove it. It's called accumulation and elimination. We have 3 common examples that we use it in active transport. First is the uptake of mineral ion by root hair. Because root hair, they will absorb 2 things. Can you guys tell me what does the root hair absorb? What does the root absorb? Root absorb 2 things, right? They absorb water, all right? They absorb mineral, very good. Water and mineral. Water, mineral. If it's water, the process has to be osmosis. Means it's under passive transport. If it's mineral, the process has to be active transport. So we have to look at the question, whether the question says that the process requires energy or not. If the process requires energy, it means that no, the answer has to be mineral. If they need energy, the example has to be mineral. It has to be active transport. If the question says no energy is needed, then the example has to be water. They will give you the same diagram, guys. The same diagram will be given to you, but you have to read the example. You're going to read the question whether they want you to write things requires energy or they don't require energy. This is the example. It's a very simple question about active transport, about root hair. But next one, we have a thing called proton pump. Proton pump happens in your stomach because in your stomach is acidic, right? Can you guys tell me why is your stomach acidic? What causes your stomach to be acidic? What is the acid name called? What is the name of acid? Correct, it's called hydrochloric acid. Very good. It has to be hydrochloric acid. Okay, in exam, you cannot write stomach acid. We're going to write hydrochloric acid. Presence of HCl. Where does the hydrochloric acid come from? Because hydrochloric means what? Hydrogen plus chloride ion, H plus Cl. So H plus Cl, where does the H come from? From this proton pump. In your active transport, energy is needed. It allows hydrogen ion to move across the carrier protein. We call this process as a proton pump. When you have enough of hydrogen ion, because it's an accumulation, you have to accumulate hydrogen ion, it causes your stomach to be acidic. This fits the criteria because it's an accumulation, right? They want to accumulate hydrogen ion so that your stomach will be more acidic. If there is no hydrogen in your stomach, you will never form a HCl. So H plus is important in your stomach when you want to form HCl so that you can kill microorganisms, so you can provide acidic medium for enzymes to react. So this is proton pump, the one that happens in your stomach. It's called proton pump. Okay, the last one is called sodium potassium pump. It happens into your any cell membrane. It's called sodium potassium pump. This sodium potassium pump, sodium in chemical formula is Na, right? Potassium is K. Remember as 3,2 pump. Why is it 3,2 pump? Because 3 sodium, 2 potassium. When you write the name, it has to be sodium potassium, not potassium sodium. So remember NaK, not okay, NaK, not KNA, is NaK. Na and K, sodium potassium pump, not potassium sodium. So it's NaK, 3,2 pump, 3 sodium, 2 potassium. If you look at the diagram, this is a carrier protein. As we have mentioned before, every carrier protein, what do they have over here? What is the pattern over here called? What is the pattern? The line that I draw, correct? They have active site, very good. All of the carrier protein, they have active site. Only the specific shape can bind with the active site. So first we have is sodium. How many sodium in total? Again, just now we have said. How many sodium? We have 3 sodium, very good. 3 sodium ion. Is it a must for you to write the 3? The answer is yes. Because this question, it could be asked in your structure or even your essay question. They will ask you to write the essay out. You're going to write the number. So it's necessary for you to know how many in total. So 3 sodium, it binds with the active site of carrier protein. Okay, then we need energy, right? It's in the form of ATP. Just now we have mentioned, triphosphate means how many? Tri means carrier protein can also carry ions, right? Ion, sodium ion is ion. Carrier protein carries ion. Sodium ion is ion. Yes, okay. So we have 3 because ATP is 3, right? Triphosphate. When you want to break down ATP, it will be broken down by ADP and P. ADP is 2 diphosphate, phosphate is 1. So they will break down into ADP 2 plus 1. So it will be 3, it will form into 2 plus 1. This phosphate group, they will bind with the carrier protein. So imagine my hand is a carrier protein, they will open, right? So this is my, imagine this is my sodium, okay? Sodium, they binds with my carrier protein. It needs an energy. This is the energy they will bind with like that. So when I want to open up, right? Open up, energy is needed. Without energy, they cannot open up. So that's why we have to remember all of the active transport requires energy in the form of ATP. Then after that, since we have energy, I can open up the carrier protein. It changes the shape of carrier protein to allow the sodium ion to be transported out of it. How do we know whether charged ion going through a channel or carrier protein? Okay, now this is a very common confused question that students always get. Whenever you see there is ATP, okay, ATP, they will only have carrier protein. If it's only carrier protein for active transport, the answer is charged ion. Because active transport only have charged ion. In this situation, active transport, we only have charged ion. So that's why, remember, active, charged ion, carrier protein. Okay? Charged ion, carrier protein. So just have to remember, active transport, you only have charged carrier, that's all. Then if it's facilitated, your carrier protein will be a large molecule. So it has to be opposing. So when you know active, then you will know the other one is opposing. Okay. Now, how do I know whether they are moving in or moving out? Because this one moving out, pump out of the cell, right? How do I know whether they move in or move out? Same goes to the diagram. We're going to count the number of substances. How many over here on top? 1, 2, 3 on top, right? How many here? 1. In active transport, they will move against the concentration gradient. Against means low to high or high to low. More to less or less to more. Correct. It will be low to high, correct? Less to more, right? So it will be in this direction, right? Less to more. So that's why in the end of the day, at this area here, you have even more. So they will pump out of the cell. Next, we have 3 sodium. How many potassium do we have? 3 sodium, 2 potassium. Very good. Can you see we have 2 potassium over here? 2 potassium, yeah? In potassium part, we don't have to use any energy anymore. So when it binds with it, the phosphate group will leave the carrier protein. They have to just go back to the original shape. Going back to the original shape, it's like a spring. No energy is needed over here. So they just go back to the original shape. Then they will allow the potassium ion to be passed into the cell. How do I know whether it's into or out? Again, we're going to count. We have 1 over here, 3 over here, lesser to more. That's why potassium ion will be diffuses into the cell. This out of the cell is elimination. Elimination. Into the cell is accumulation. So it fits to the purpose, right? Accumulation and elimination of substances. This is what it is. Elimination and accumulation. This sodium potassium pump, it will be a question that you will see in your exam. Usually is about 6 marks now, okay? If it's an essay question, your first exam, usually your first term exam, this is one of the popular asked essay question. Only on your first exam. The rest no more already, guys, okay? So this is your essay question, about 6 marks. It can also be a structure question actually. But if it's an essay question, it can be 6 marks because we have 6 sentences over here. What is the function of potassium over here? In your body, we have to use a lot of charged ion. Sodium is to make sure that you have no muscle cramp. Potassium, it can also prevent you from having a muscle cramp. So we have a lot of function by using ion in our body actually. We will learn more about your ions in your body in which particular part. So this sodium potassium pump. Okay, anybody has question about active transport? Remember, active and passive is opposite. One requires energy, one does not require energy. One move down the concentration gradient, the other one move against concentration gradient. One is to achieve dynamic equilibrium, the other one is to accumulate or to eliminate substances. This is active transport. Anybody question? These 2 pages here? No? Okay, we're gonna try some exercise right now. Before we move to the last part, we're gonna try some exercise first before you forget things. Okay, let's flip to your question right now. We're gonna try first and then we're gonna move to the last part later on, yeah? Okay, flip to your question. Page 1. If you have no notes with you, what you can do is you can just go to the website, TTC Education website, and you just click to the PDF notes. You can just download the notes and you can write it in your iPad or whatever, or just print it out by yourself, or you can just request the notes. Okay, diagram 4 shows the process of movement of substances across plasma membrane. We're going to start with the first question, yeah? Based on diagram 4, name the type of movement. So if you look at L, there is ATP. Whenever you see ATP, it has to be what transport? Whenever you see ATP, it has to be, correct, it has to be active transport. It has to be active transport. Next, if you look at M, okay, obviously M is passive transport, but if you want to write the specific answer for M, do you notice that it uses carrier protein and also channel protein? They move along the concentration gradient, which is move down the concentration, more to less, right? They uses carrier and also channel protein. The answer is facilitated diffusion, correct? If you want to write the answer, for passive transport, I will suggest you to write the specific one. Because if you write passive transport, most of the time your answer is not specific enough. You have to write the specific answer. Just write facilitated diffusion. Facilitated diffusion. Or the rest of the answer, you can choose to write simple diffusion or osmosis. It cannot be osmosis because osmosis don't have to write. Osmosis don't have to write this thing. I mean, they don't have a carrier protein in osmosis. This is page 1 of your exercise. Page 1 of the exercise, yeah? Okay, state one example of substance that is able to move across the plasma membrane at M. Can you tell me any substances that are able to move across this? We're going to go through one by one. If it's fully open, is this a carrier protein or a channel protein? If it's fully open, it will be a channel protein, correct? This will be a channel protein. Then obviously this one is a carrier protein, right? This is a carrier protein. Okay, so since this is a channel protein, if it's a channel protein in facilitated, what is the example that's able to diffuse across it? If it's a channel protein, the example that are able to diffuse across it will be, correct, the charged ion. How to know which is which? Because if it's a channel protein, it will be fully open. It's a straight line. If it's a carrier protein, they will have a pattern in the middle. Can you see there's a pattern in the middle? When you see pattern in the middle, this is a carrier protein. Okay, so for channel protein, this has to be a charged ion. Any charged ion, it can be sodium, potassium, whatever, okay? It can be either one over here, sodium, potassium. Okay, if it's a carrier protein, it will be a large molecule. Large molecule, what is the example of large molecule do we have? We have glucose. What else? We also have amino acid. So you can choose either one here. Correct, amino acid, glucose. Just write any one example. You can choose to write glucose or amino acid, whichever one, guys. You can choose sodium, potassium also can because they just say M. They didn't say which one, they just say M. So it's a very general one, just write whichever that you want. Differentiate both process L and M. If it's 2 marks, sorry for the example. So for the example, I also have to include carrier protein. Just state the example. Don't have to write the carrier protein or channel protein. Unless the question asks you to write accordingly to the protein itself. Okay, to differentiate process L and M, 2 marks, you're gonna write 2 differences. The easiest one to write between these two is whether they need energy or not. Does active transport requires energy? Does active transport requires energy? Yes or no? Yes, right. Okay, so you're going to write requires energy in the form of ATP and does not require energy. Does not requires energy. So don't have to write in the form of ATP. Next, we're going to say whether they move down or move against the concentration gradient. So process L. L is the one active transport, right? Active transport is move down or move against. Correct? They move against. Very good. So you're going to say substances move against concentration gradient. Move against concentration gradient. This one, substances move along concentration gradient. If you want to write to achieve dynamic equilibrium or to accumulate or to eliminate also can. Can you write move down? Of course you can. Move down, move along, or you can also write follow also can. So when you write in exam, because if it's a structural question, you're not supposed to draw it in a table. Because I give you a table, you can write it in a table, right? In exam, you're going to make it into a sentence. Your answer has to be L requires energy in the form of ATP, whereas M does not require energy. It has to be one sentence for difference. If you write for any differences, everything has to be in one sentence. Remember that, okay? L requires energy in the form of ATP, whereas M does not require energy. Everything has to be in one sentence. You cannot write L requires energy, full stop. Okay, next sentence, M does not require energy. You're not comparing. What is a differences means you have to compare, right? It's like I cannot say I am tall, full stop. Nobody know I'm tall. You have to say I am taller than a kid. Then you are tall. I am shorter than a person who is 180. You have to compare. Only you can write for differences. You cannot say I am tall, full stop. Nobody know that you are tall, guys. You're going to compare to someone else. Done with this page? Done, let me know. I'm going to wait for 5 of you. Done, let me know, yeah? Okay, done. We're going to move to the next question, guys. The following substances are required by body cell to carry out process of metabolism. Explain how oxygen is transported into the cell. So how do you get oxygen? Oxygen is by what process? Oxygen gases is by? Based on the one that we learned just now. They are under simple diffusion. Very good. They are under simple diffusion. If it's a simple diffusion, they will move down or move against the concentration gradient. They will move down. Very good. So to write your answer, first you're going to say oxygen is transported into cell by simple diffusion. So you're going to say oxygen moves from higher partial pressure to lower partial pressure. True? Okay, now, so if you want to write through which part, you can write about the simple diffusion. Partial pressure is concentration, yeah? It's like water, you're going to write water potential. For gases, you're going to write partial pressure. You will learn this word in chapter 8. If your exam has chapter 8, then you're going to write partial pressure, guys. Because partial pressure is the correct word of writing for gases. For oxygen and carbon dioxide, we're going to write partial pressure. So partial pressure is the concentration. Again, my question is, if it's a simple diffusion, they move across the phospholipid bilayer, channel protein, or carrier protein. The answer is phospholipid bilayer, correct? So you're going to write through phospholipid bilayer. You move phospholipid bilayer, correct? Glucose and amino acid enter through the cell through specific site of a protein in the plasma membrane. Explain why. Okay, first, glucose and amino acid, they are what characteristic do we have as a glucose and amino acid? Correct. They are large molecule. Very good. They are large molecule. If it's a large molecule, they have to use which protein? Correct. They have to use a carrier protein. Very good. So because they are large molecule, they have to use carrier protein with a specific site. Through which transport? For carrier protein, glucose amino acid, it will be what transport? What? Not active transport. It has to be facilitated diffusion. The transport is called facilitated diffusion. When you write, you cannot write passive. You have to write facilitated diffusion. So to write your answer, we're going to write glucose and amino acid are large molecule. This molecule enters carrier protein and that has a specific site, that has a binding site also can, active site also can. Binding site lah. Binding site. And it has a binding site. True, don't have right end. True. Facilitated diffusion. You can write active site. Whichever one is okay. Okay, done with this. Let me know. I'm going to wait for 5 of you to finish this. We're going to move to the next question, okay? 1, 2, 3, 4. Okay, more than 5 already, guys. Okay, now done with this, we're going to move to the next question. Diagram 3.1 shows the substances across a plasma membrane. They ask, name structure P. From this diagram, can you see there is ATP? When there is an ATP, it means what transport is this? This is a active transport. Very good. Okay, let me write over here. The process here is called active transport. This is active transport. Okay. Now, since this is an active transport, we have to know what is P. In active transport, what do we use? What protein do we use? We only use what? Correct, a carrier protein. Very good. So P, it has to be a carrier protein. And they only open one part right now. Okay, now we're going to look at what is Q and R. Yeah? Can you see Q and R? We have 2 different colors. And if you count, how many here in total for your Q? 3, right? If it's 3, what is this ion? It will be a sodium, correct? So Q is a sodium ion. What about R? R will be, if one is sodium, the other one has to be potassium, correct? Potassium ion, very good. Okay, sodium, potassium, okay? Now, next question. Name the type of transport. Okay, since we say this is an active transport, just write it again. Active transport. Next question they ask, Q and R are ions that involve in sodium-potassium pump. Explain the transport of ion Q across the plasma membrane. Ion Q is your sodium ion. So we have to say 3 sodium, they binds with the active site of the carrier protein. So it will changes the shape of a carrier protein with the help of, do they need energy over here? In the diagram, do they need energy? Yes, right, okay. How does 3 shape equals to 3 sodium? Because 3 sodium, 3, 2 pump, 3 sodium, 2 potassium. These are the ions. These are the ions over here. So 3 sodium, 2 potassium. And they have different binding site. So actually you can just see what are these. Because the shape, it can be any other shape. So the shape actually doesn't matter one. It's the amount of it. How many of it binds with the protein itself. So the shape doesn't matter, only the amount matters in the diagram over here. Okay, we need energy, right? It's in the form of ATP. So when there's energy, they will release energy and it will change the shape to allow your sodium ion to pass through. Since we never write Q is a sodium ion, when you write sodium ion, you have to bracket Q. Or you can just write Q if you want to. If you don't write sodium ion, you can just write Q. So you're going to say 3 sodium ion. Q binds with active site of carrier protein. You're going to say ATP is needed to change the shape of carrier protein. Then we're going to write, these enable sodium ion, which is Q, to be transported out of cell against concentration gradient. Against concentration gradient. In exam, you can write like that. Don't worry about it. You can write like that as long as your sentence is a short sentence. Don't have to be in a paragraph unless your teacher wants you to write it in paragraph. So writing this way is totally fine, guys. You can write like that in exam. As long as your answer is a short sentence. Cannot write keywords. Cannot just say, oh, Q, go to carrier protein full stop. So your answer is not complete, right? So your answer is not correct. So your answer has to be a short sentence. Done? Let me wait for 5 of you to finish this. We're going to move to the next question. One, two, three, 4. What do you mean by do you like having seminar? Having seminar is like a teaching. It's a class. Okay, diagram below shows the proton pump found on epithelial cell that lines with the stomach cavity. So when we say stomach cavity, we have to know we have hydrogen ion, right? So this hydrogen ion is under which process? Is under which process? If it's hydrogen ion, stomach cavity, correct, it has to be active transport, correct? Because they ask you what is the process, right? So the answer is active transport. Active transport. Next, explain how process stated in 1 occurs in proton pump. So in proton pump, we requires energy, right? They will move against the concentration gradient. So your answer is, you're going to say energy in the form of ATP is needed to enable hydrogen ion to be transported by carrier protein. If you need one more sentence, you can say accumulation of hydrogen ion causes your stomach to be acidic, but you can write that as an importance. They ask you to write the importance of proton pump in human body, right? The importance of proton pump, everybody we need proton pump, is to accumulate hydrogen ion to make your stomach to be more what? To allow your stomach to be more? Correct, to be more acidic, very good. If your stomach is not acidic enough, you will have no food to be digested, which is protein cannot be digested. So you're gonna write to provide acidic medium in stomach cavity. So provide acidic medium for stomach cavity. Okay, done? I wait for another 2 more of you, yeah? One, two. What is the difference between cavity and medium? Cavity is more like a space, like there's empty spaces. Medium, they will be, sometimes it will be fluid inside for medium, but they are generally almost the same thing. But usually cavity, we refer to a place where they have spaces. It's called cavity. Okay, done. We're gonna try one more question before we move to the next part. Okay, we're gonna flip. Okay, we're gonna do one more question, yeah? Yeah, forgot to delete this. Okay. Let me discuss this with you. I'm not gonna do this question, but I'm gonna discuss this question with you. So 4.1 shows two types of movement of substances across plasma membrane. Okay, if you look at this diagram over here, right, we have to recognize the S and T. If you look at S, what do you think S is? S is a what? S is a simple diffusion, correct? Because this is alveolus and blood capillary. So this is a simple diffusion. We're not going to do this question, but just for you to know, simple diffusion. We have carbon dioxide and oxygen. In exam, sometimes they will give you example. They ask you which one is oxygen, which one is carbon dioxide. They will draw for you to see. Maybe they will draw like that, okay? Agak only lah, guys, okay? Like that, okay, they draw like that. And the arrow shows in this direction. They ask you, is this oxygen or carbon dioxide? The arrow shows in this direction. They ask, is this oxygen or carbon dioxide? The answer is this is oxygen. Why? Because oxygen will move from high to low concentration gradient. Higher to lower concentration gradient means they always move from more oxygen to lesser oxygen. More to less. If they give you another diagram, for example, like that, okay? Something like that lah. Just simply draw a few over. Simply draw a few over here. Yeah. Okay, they ask you, if the labeling part is in this direction, they ask you what is this? This is a carbon dioxide. How do I know this is a carbon dioxide? Because they move from more to less. So in exam, they will not give you the name itself. They ask you to write the name of the example. They ask you to state the example given to you. So we have to know everything move from more to less. In our alveolus, we have more oxygen, lesser carbon dioxide because of inhalation. When you inhale, okay, it goes to your stomach, right? So it goes to your alveolus, right? So that's why your alveolus will have more oxygen. Next, we have this diagram over here. Can you see there is ATP? When there is ATP, what process is this? This is a active transport. Very good. This is an active transport. As an active transport, it requires energy. The example will be, if it's a root, what is the example? It can be any mineral salt, correct? It can be any charged ion, sodium, potassium, magnesium, whatever charged ion also can, because this is active transport. So this is a very popular ask comparison question. They ask you to compare between alveolus and root hair cell. For some reason, it will always be these two questions. I don't know why lah, but it's always blood capillary and root hair cell. Why? It can be mineral because they are a combination of a lot of things. So it can be mineral salt, it can be mineral ions. So mineral salt can be NaCl, no, it's called mineral salt. If it's a mineral ion, it will be sodium only or calcium only or chloride only. So, but doesn't matter whether it's mineral salt or mineral ion, guys. So this question 4, I'm not going to do this, just for you to see. Sometimes they will also ask you to compare about these two things. Because a lot of questions, so I'm just giving you an example only. Yeah, for example, this one question 2, they also give you something like that. They ask you to write between these two. If you look at these two, both of these are what protein? Both of these are what protein? Both of these are, they are a carrier protein. How do I know this is a carrier protein? Because they only open one part, right? So this is a carrier protein. This is also a carrier protein. Both are carrier protein. The differences between these two, it will be the energy. There is energy over here. There is no energy over here. One is with energy, the other one is without energy. So when you see energy, this one has to be active transport. When you see without energy, what process is this for Y? This is You cannot write passive transport. It has to be the specific one. It has to be facilitated diffusion. It has to be the specific answer. It cannot be passive transport only. So they always ask you to compare these two diagrams. So this is a very common asked question, active and facilitated. And also between your alveolus and your root hair cell, for some reason, is always a question that you see in your exam. And one more, it will be this. Look at question 5, okay? Question 5, we're going to do this together, question 5. 1.1 shows two regions M and N. Based on 1.1, which region has a higher water potential? We're going to count the number of sucrose in the diagram first. How many sucrose do you have in M? How many sucrose in M? 1, 2, 3, 3, right? How many in N? 1, 2, 3, 4, 5, 6, 6, right? So as to compare, the one with lesser sugar will have more water. So the answer is M. And they ask you why. Because you're going to say M has lesser sucrose molecule compared to N. Your explanation is M has lesser sucrose molecule than N. M has lesser sucrose molecule than M. Can I write concentration? Of course you can. Just write molecule. You mean what? Sucrose concentration? Are you trying to say this? Sucrose molecule. Why? Because the question given to you, it was a molecule. So you're going to write molecule. Can I write more water instead? You can say M has higher water potential than N, also can. Has more water molecule, also can. N to N. Can I reverse the answer? Means what? N has more sucrose than M? Is it? Yes, you can. Okay, draw a result after 30 minutes. So after 30 minutes, do you think the number of sucrose in M on N changes? No, right? It remains the same, right? What changes? The water molecule, the water level changes. So when you draw, you outline the diagram first. I'm going to draw a YouTube over here. A bit ugly. Outline first. Something like that, guys. Okay. Cannot draw very well, but something like that. In between, we have a semi-permeable membrane. The semi-permeable membrane, you have to draw it out. And then we're going to draw 3 on the M side and 6 on the N side. 3, water level, 1 lower, 1 higher. So 3, 1, 2, 3. 1, 2, 3, 4, 5, 6. You're going to draw water as well. Water, you're going to draw dot, smaller. Do we have to label the sucrose molecule? If the question asks you to draw a label diagram, you have to label. But actually, I always tell my students, whenever you draw, you just label. Because sometimes, I don't know why, your eyes cannot see the word label. So whatever thing that you draw, just label it. Whatever that you draw. Even that the questions did not ask you to label, you can still label it. Even if you label wrongly without a labeling question, it's okay because it's just drawing the diagram. So the best way is just to label everything. Just label this is water molecule. This is a sucrose molecule. When you draw, it has to be a pencil. When you label, can be a pencil, can be a pen. But when you draw, it has to be a pencil, yeah? How do you know how many water dots do we have to draw? The water dot doesn't matter. The water is random. But only sucrose you have to count. Because water can move in and out in 2 directions. It's a both-way movement for water. Okay, explain the process above. What process do you think this is when they are only related to water? Correct, it has to be osmosis. Very good. Everything here is osmosis. Water always move from more to less. They will move from M to N. Is to achieve what? To achieve? Correct, to achieve dynamic equilibrium. Very good. So your answer is water diffuses from region M to region N by osmosis. Dynamic equilibrium is achieved. Dynamic equilibrium is achieved. Do we have to draw until the maximum amount of water molecule? Don't have to count, because they only count the sucrose. Because water move in both directions, so actually you don't know whether they move in or out in that particular area or not. So water don't have to draw, don't have to count. But if you want to count also can lah. If you want to draw 7 also can lah. But water don't have to count. Only get to count the sucrose. Do we write diffusers through selectively permeable membrane? If you want to, you can, because sometimes the question is 2 marks or 3 marks. So depending on the mark, so you can choose to write through selectively permeable membrane. But you have to write osmosis. The main thing here is to write osmosis actually. Okay, done with this? I'll wait for 5 of you to finish this. We're gonna move to the next question right now. 1, 2, 2, 2, 3. In XPM, do we have to label? If the question asks you to write a label diagram, draw a label diagram, then you have to label. The question will say to you, draw a label diagram, or just draw. Actually, if it's just drawing, don't have to label. Unless the question says draw a label diagram. Okay, now 2.1 shows 2 region X and Y which are separated by a semi-permeable membrane. Complete diagram 2.2 after 30 minutes. To draw this, again, we have to count the sucrose. For X, how many sucrose do you have? 1, 2, 3, 3, right? Okay. How many do you have in Y? 1, 2, 3, 4, 5, 6, 7, 8. 8 in total. So to draw this diagram, water molecule in X or Y is higher after 30 minutes. Correct. Y is higher, right? Lower, higher. Still, same thing. Draw 3 over here. 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8. And then you're going to draw water. Okay. Just label, guys. Don't worry. Just label whatever that you draw. Water molecule. Sucrose molecule. Remember to count the sucrose. Sucrose is the most important thing that you're going to do. Okay, C, desalination process is a process to produce fresh water from seawater. 3.2 shows desalination to obtain fresh water from the seawater. Based on 3.2, explain the process. What if the sucrose that we draw is one big, one small? As long as they are bigger than the water, your sucrose has to be bigger than the water. Okay, now what is the desalination process? This process here is to produce a drinking water out from the seawater. The process here is called reverse osmosis. You know, there's a type of water that we drink in whatever, whenever you buy from KK 7-Eleven, there's a type of water called reverse osmosis water. Reverse osmosis, it means they have to use a seawater to make it back into drinking water. What is the reverse osmosis? Osmosis means what? Water move from more water to lesser water. It's called osmosis, right? Reverse osmosis is where they will move from lesser water to more water. If you look at this diagram, we have more salt, more sucrose, and more sand over here, right? The purpose of having this is to apply a pressure. The water can diffuse across only water. There is no other substances, only water can diffuse across. So this is what we call as reverse osmosis. By using seawater, mainly is seawater, okay? Seawater, we apply pressure, allow only water substances to pass through to produce into a drinking water. We call this as a reverse osmosis. So to explain in sentence, because this is actually in 3.4, your application question. But again, as osmosis, I'll just talk it together lah. So you're going to say reverse osmosis process. So you're going to say in reverse osmosis, pressure is applied to seawater that pass through selectively permeable membrane. It only allows water molecule to pass through, but salt large molecule and microorganism are blocked. Then let me know, yeah. Wait for 5 of you. One, two, three. Three. Four. Five. Okay, very good. Should I write substances? Molecule is the same. Don't have to write atom, but you can write ion, you can write molecule, you can write substances. We don't write atom in biology, but in biology, they are the same thing. Okay, now, done with this? Okay, so you're okay with passive and active transport, right? We're going to do the last part. The last part is the most important part that you apply to 3.3 and 3.4. Okay, flip back to your notes, guys. Flip back to your notes. Flip back to your notes. Okay, we're going to do the last part. This is 3.3. We can also use it in 3.4. It's a movement of substances across plasma membrane in daily life. We have 3 different solutions. We have hypotonic, isotonic, and hypertonic. What is the meaning of hypotonic? Hypo means more water, lesser solute. What does solute mean? Anything that is not water, we call it as solute. It can be salt, it can be sugar, it can be vinegar. As long as they are not water, we call it as solute. It's called hypotonic, more water. Isotonic means what? It means they are equal. We call this as isotonic. Everything is equal. The water and the salt is equal. It's called isotonic. Next, hypertonic means what? Lesser water, more solute. Lesser water, more solute. This is wrong. Like this is more solute, guys. It's more solute. Okay, lesser water, more solute. Less water, more solute. You just have to remember that when a person is hyper, okay, when a person is hyper, they get excited, they loses a lot of sweat, so lesser water, but more solute. So remember, hyper means less water, hypo means more water. You have to understand the name first, only you can apply to all of these examples over here. We have 3 different types of example: red blood cell, or you can say animal cell, plant cell, and mustard green cell. These 2 things are actually the same thing, but plant cell can only be seen under microscope. Mustard green cell, you can just use your eyes to see it. So this is without a microscope, this is with a microscope. Okay, starting with the first one, we have animal cell. Animal cell has no cell wall. So they will burst, they will strings, they will changes in their shape itself because there's no cell wall. I have a hypotonic solution. I have a red blood cell right now. Okay, imagine this. How do we define it as a hypotonic solution? We have a type of example that is always shown as a hypotonic. The best example to write as a hypotonic solution, it will be distilled water. Distilled water is 100% water. It's always hypotonic, guys. Distilled water is always hypotonic. As to compare to distilled water and red blood cell, which one has more water? Distilled water, red blood cell, which one got more water? Which one? Red blood cell? Distilled water, of course, the distilled water, right? Distilled water, of course, is 100% water, right? Distilled water has more water. Water will diffuse into the red blood cell. Why? Because this is osmosis. More water to lesser water. When water diffuses into it, the red blood cell will burst. Why will the red blood cell burst? Because there is no cell wall. The bursting of red blood cell is known as hemolysis. What is the word hemo means? Hemo means red blood cell. Lysis means breakdown. Breakdown. So whenever you see the word lysis means breakdown. So because of water keep on diffuses into it, the red blood cell will burst. It's called hemolysis. Expand and burst. You just burst. Okay, now next I have isotonic solution. In red blood cell, how do we define it as an isotonic solution? The example that we always give as an isotonic, when you see people who got admitted to the hospital, you know, sometimes when you admitted to the hospital, the doctor give you IV dripping. The IV dripping itself usually are salt solution. The salt solution has a percentage. It's at 0.85 to 0.9% of NaCl solution. NaCl is salt solution, NaCl solution. The percentage has to be at 0.85 to 0.9 because this solution is the same percentage as your red blood cell. So when water diffuses in, they will not cause the red blood cell to change in any structure. So because let's say the reason why you admit to hospital maybe because that you have dengue, you have diarrhea, or maybe you have dehydration. So you go for IV dripping, the solution that goes into your body, it makes you it replenish your water loss. So the solution is the same as a red blood cell. So water diffuses in and water diffuses out at the same rate. We call this as no net movement of water. No net movement of water, it means same. It doesn't mean no movement. What does no net movement of water means? It means, let's say right now, I give you 10 ringgit. You're going to return me 10, right? Right now, like that, we call this as no net movement. What is movement? Movement means what? I give you 10 ringgit, you only return me 4. You net gain 6. I net loss 4. It's called movement, okay? So remember, no net movement means same. It has to be the same. Water diffuses in and water diffuses out at the same rate. It's called no net movement. Next, we have hypertonic. Hypertonic means what? Hypertonic means that they have lesser water. What are the examples of hypertonic? You can apply to any cell over here. It can be sugar, it can be salt, it can be anything. So let's say I just write salt solution. It can be any percentage. Let's say right now I have 5% of salt solution. Or maybe I have 10% of sucrose solution. It can be any percentage, guys. Not necessarily have to be 5 or 10. It can be any percentage. 10, 15, 20 also can, whichever percentage also can. So this is hypertonic. So again, let's say I have a very concentrated salt solution. And I have red blood cell right now as to compare. Which one has more water? The red blood cell has more water or the concentrated salt solution has more water? Which one has more water? The what? The red blood cell, because red blood cell is just more water and lesser sucrose, a lesser salt, right? So red blood cell has more water. So the water will diffuse out from the red blood cell. That's why red blood cell will shrink. Shrinkings of red blood cell called crenation. What is the percentage to make it hypertonic to red blood cell? There is no percentage. You have to see whether they are concentrated or not. But for red blood cell, it has to be more than 1 because 0.9 is isotonic, right? Anything that is more than this, for red blood cell is 1% actually. For red blood cell only not. The plant cell and mustard grain cell is very depending one. Only for red blood cell is 1. More than 1 is considered as hypertonic to human red blood cell. Okay, so this is crenation. Next, we have plant cell. Plant cell is different because plant cell has a cell wall. Distilled water and plant cell, which one has more water? 1% as in solid percentage, yes. Plant cell and distilled water, which one has more water? Of course, distilled water has more water, right? Water diffuses into the plant cell. When water diffuses in, the vacuole becomes very big in size. We call this as turgid. So turgid is where there's a lot of water in the vacuole. It's called turgid. They expand, correct? The vacuole expands, it becomes big in size. Next, if it's isotonic, it means it's the same. As we have mentioned, if it's the same, we have to write no net movement of water. No net movement of water. Okay, no net movement of water. Okay, in this situation over here, we have to use the word flaccid. Actually, I will not suggest you to write flaccid, even though the textbook write flaccid in isotonic solution, because turgid and flaccid, they have opposite meaning. Means whenever you see turgid becomes bigger, right? Flaccid is supposed to be smaller, which is this one. But the textbook wrote flaccid as isotonic. So if you want to write an exam, I would suggest you to write remains unchanged, or you can just write no net movement of water. No net movement of water or remains unchanged. If it's hypertonic solution, hyper is different. I have 10% sucrose solution, for example, plant cell. Of course, plant cell has more water, right? Because so concentrated, the water in plant cell diffuses out. The vacuole becomes smaller in size. The plasma membrane pulled away from cell wall. Okay, these we call this as plasmolysis. Actually, when we are looking at plant cell, animal cell, or even mustard green cell, we have to know how to draw. Okay, we're gonna start from red blood cell first. I'll come back to mustard green cell later, because mustard green cell, it requires a bit of thinking later. I'm gonna draw red blood cell again. How do you want to draw a red blood cell? We're gonna draw a bursting red blood cell, where it's supposed to look something like that. Circle, and then it bursts, and then dot, 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 dot. This is a bursting red blood cell. In exam, they will ask you to draw. So you're gonna draw this, okay? Dot, okay? Draw, guys, in your notes. Draw in your notes. In exam, they ask you to draw. If you want to draw a plant cell that's bigger in size, first draw cell wall. Okay, you draw plasma membrane, and then you draw a big vacuole. It has to be very big, guys, because it's turgid. Nucleus, dot, 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 dot. This one. You're gonna draw a very big one. If it's a bit fat, also never mind. Just draw a very big one. This is how we draw a plant cell. When you draw, remember to draw it in pencil in exam, okay? Now, isotonic for red blood cell, they don't really ask you because it remains unchanged. But for plant cell, they will ask you to draw it out. How do you want to draw a plant cell? Same thing. Cell wall, plasma membrane, and then the vacuole has to be smaller than the previous one. Like that. Smaller than the just now that one. And then dot, 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 dot. They will ask you to draw isotonic for plant cell. Okay, so if it's a hypertonic, how are you supposed to draw? You're going to draw a bursting red blood cell, right? Something like that. Like sun. You know how you draw a sun? If you want to be more artistic, you can draw two lines inside. No purpose one, guys. It's just to show that you are more artistic. Okay, no purpose one. So this is how we draw a bursting red blood cell. If it's a plant cell, same thing, draw a cell wall. Okay, and then draw one more layer. Plasma membrane actually has two layers. So plasma membrane will actually pull away from cell wall. When you draw, remember to draw like that. The edges has to stick with the line. How you want to draw doesn't matter. Okay, just show that they are being pulled away. The vacuole has to be super small in size. The nucleus, dot, 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 dot. This is how we draw a plasmolysis. In exam, you're going to draw it out, guys. Drawing is a question that you will see in the exam. So when a cell undergo plasmolysis, right, in what situation the cell undergo plasmolysis? For example, when the soil has no water, you forgot to water your plant, the plant undergo plasmolysis. Or maybe you put too much of fertilizer, the cell undergo plasmolysis. Do you think when the plant is undergoing a wilting process, haven't died yet, but it's ing, wilting process, can you still save your plant? Of course you can. How can you do it? Correct, you put water inside, right? Okay, you can put water, you can reverse the diagram. So by putting water the plant, the reverse process here is known as deplasmolysis. Deplasmolysis is where you reverse it. When you use the word turgid, when you use the word deplasmolysis, because these are the two same diagram, right? When the question says a plasmolyzed plant cell is being immersed into distilled water, then your answer is deplasmolysis. The question says a plasmolyzed plant cell, deplasmolysis. The question says a plant cell, your answer is turgid. So it's very depending on the questions, whether they say it's a plasmolyzed plant cell or plant cell. So plant cell can reverse, animal cell cannot, because animal cell don't have. Flooding is different. Flooding is because of other reasons. It's not because of this. Because when they flood, the plant produces alcohol, ethanol out. So flood is different than this. Okay, now next, after drawing this, only plant can reverse, I remember, is when it becomes turgid again. So when you draw, you're going to draw this because it becomes turgid again. It's a reverse diagram. It's called the plasmolysis. So that's why if you go to some market, you can see that the person who sells the vegetable, they always spray water onto their vegetables because they want to make sure that their vegetables always in turgid state. When you spray water on the vegetables don't look like they are dying. So this is how they keep their vegetable fresh. It's the same thing. It's a deplasmolysis process actually. Okay, the last one is called mustard green stem. What is a mustard green stem? You can cut potato strip. You can also use a mustard green stem. You can also use a spinach stem. Have you all tried this experiment in school? Like when you cut it and then you immerse into different solution. Some of the school teacher will ask you to do it. Or it can be a paper 3 question actually. Paper 3, they will also ask you to do this experiment because you can have your result immediately, about 10 minutes. Potato strip, okay, yeah, it cut with the stream, right? So when you do this experiment, don't have to use any microscope. You can see with your eyes. When you're looking at the mustard green stem, you have to find a thing called cuticle. Cuticle is the one with a waxy layer. This part here is a cuticle. This is a cuticle, it's a waxy layer. It's a waxy layer. Okay, this is a waxy layer. This waxy layer, it will not take in any water. There is no water in the waxy layer. When you immerse into distilled water, the water diffuses in or out from the cell. Which one? In or out? When you immerse into distilled water, is it in or out? In, correct. Water diffuses in. They curve outwards. They become fatter over here. They curve outwards. Next, cuticle, they don't take in any water. If it's in an isotonic solution, water diffuses in and out at the same rate, called no net movement of water, remains the same, nothing changes. If they put it into a hypertonic solution, same thing, cuticle don't take in any water. Water diffuses in or out from the cell. All right, out. Cortex is the flesh, yeah, we call this as cortex, is the flesh of it. Drawing is a question that you have to know in class. I mean, in exam, you have to know how to draw this diagram. Some people always memorize the direction. They say this is an inverted C, this is a C. You cannot memorize this way. You cannot say this is an inverted C or C because they might draw it in the other direction for you to see. What you can imagine is, you can just imagine this as a human. You know, human, we have backbone. Imagine that cuticle is a backbone. It's a backbone of a human. This is a backbone. You know how pregnant women walk? Pregnant people always walk with their hands on the back because got baby in front. They have to hold their backbone, right? So imagine this is a pregnant woman. Imagine, okay? So this is the head. This is the hand on the back, okay? And this is the leg. And then the baby is in front. So it's like a pregnant woman. So the red color part is the backbone. Okay, so they are holding their back. So imagine that water diffuses in. It becomes the curve outward, right? Got baby in front. So curve outwards. This is what we call as curve outwards. Water diffuses into it. You have another direction of this thing. Let me draw another direction for you to see. It can be like that. This is a cuticle. A bit ugly. Let me draw nicer a bit, guys. And then it curves outwards. It curves outwards. This is how it looks like. Curve outwards. So same thing, it's like a pregnant woman. Head, hand, leg, baby, water diffuses in. See two pregnant women conversate. Okay, so just imagine that they are pregnant women. Then you know this is curved outwards, water diffuses in. This is how we draw. The cuticle, you're going to draw it out. In exam, it will indicate the cuticle for you to see. If there is no cuticle, it's just become big in size. There's no curvature when there is no cuticle. So they must have a cuticle. If they remain the same, means no changes. But if it's curved inwards, how can we imagine this thing? We imagine that this is like a old people. You know how old people walk? They walk with a tongkat. Imagine they are old people. The cuticle is the backbone, the head, the leg, the tongkat. They're holding a tongkat like that. Imagine this is the old people. This is what we call as curved inward. Water diffuses out. In another direction, it should look like that. Curve inwards, the cuticle. Curve inwards. Okay. Then this is the head. This is the leg. This is tongkat. Like that. Okay, same thing. Curve inwards. We did the experiment on the potato, but I think we did it without epidermis. If you did it without epidermis, it didn't curve, correct? Because you have to do it with the skin if you want to see the curvature. So you're supposed to cut with the skin. If you want to see whether they curve or not. You cut without the skin, is it? You cut without, you remove the skin when you cut a potato. Yes, then there's no curvature. You just feel whether they become turgid or not only. So if you want to see that they curve, you have to cut with the skin. But I know that you guys use molding that you chop and then you did it with the same size, right? Will they ask us to use without, will they ask a question without epidermis in the exam? Yes, they will. But it just remains the same. When there's no cuticle, then it becomes bigger in size like that. Just become bigger in size. No more already. It's just like that. No changes one. Well, crenation happens inside our body if we eat too much of MSG. If you take too much of salt, yes. Actually, crenation happens to people with diabetic. When they have diabetes, high in sugar level, their red blood cell has crenation. That's why they always get lacking of oxygen in their body. So human will also get crenation when they have certain disease. So this is what we call as curve in and curve out. So remember, don't memorize C or curve, inverted C. Remember how you're going to draw it. Drawing is a question that you will see in your exam. So now that, can you draw? Can draw, right? Okay, now after knowing how to draw the diagram, you have to know how to answer the question. We have an answering technique I'm going to teach you today. This answering technique, you can use it in 3.3 and 3.4. Use it in paper 2 or even in paper 3. Use the same answering technique, okay? This answer, literally, you can answer a lot of questions. You're going to repeat the same question, answer later. Okay, you can write it in any part that you want, as long as it's empty. The answering technique, yeah? First sentence that you're going to write is term. What is term? The one I highlighted in blue color, can you see all the blue color words are term? So the first sentence is going to say, the red blood cell undergo crenation, hemolysis, or the plant cell undergo turgid or plasmolysis, the term. Second sentence you're going to write is hypo or isotonic. So you're going to say red blood cell is hypertonic to the cells, to the cytoplasm of red blood cell. When you compare, you have to compare between A and B. Distilled water is hypotonic to the cytoplasm of red blood cell, or they are hypertonic to the cytoplasm of red blood cell. It's always A is hyper to B, or B is hypo to A. Remember, you're comparing. Comparing, you have to use two subjects. It's called comparing. Third sentence, we have to use water molecule. Water molecule, whether they diffuses in or diffuses out from the red blood cell, plant cell by osmosis. You're going to write by osmosis. By osmosis is important. The fourth sentence, we're going to write explanation. How do we explain? We explain based on your red blood cell or animal cell and plant cell. Okay, as a red blood cell, how are we supposed to write it? Red blood cell, we're going to say it expands and bursts or shrinks. Choose either one depending on the question, or either one. Plant cell, you're going to write vacuole, expand, or shrinks. The other one, you're going to write plasma membrane, push against, or pull away from cell wall. Push against or pull away from cell wall. Okay, when you want to write for a red blood cell, because we have to compare, right? When you write for a red blood cell, we have to use the word cytoplasmic of red blood cell. If we want to write plant cell, we're going to write cell sap of plant cell. Cell sap of plant cell. Cytoplasmic of red blood cell or cell sap of plant cell. Cytoplasmic is a cytoplasm. It's called cytoplasmic. Okay, so this is the answering technique for the question just now, the 3.1 and also 3.3 and 3.4. We're going to apply this answering technique later in question. After you have done writing with this, you let me know. Yeah, wait for 5 of you to finish writing this. One, two, three. You will get an answer. I will post the answer in the website. You can just go to the website to get the answer. By Saturday or tomorrow, you can get the answer there. It will be in the website. Then let me know, guys. Yeah, TTC website, the link that you got into it, the TTC website. Yes. Two more? Then let me know, okay? Four. Five. Okay. Done, yeah? Very important answering technique. We're going to apply it into question right now. Okay, flip back to your question, guys. Again, to your question again. Okay, let's look at question 6. Remember, use the same answering technique for all questions. Question 6. 2.1 shows 2 red blood cells in solution of different concentration. State the type of solution for X and Y. First of all, let's look at the diagram. In the diagram over here, can you see that the red blood cell, is it becoming bigger or smaller? The red blood cell in the one on the left side, which is P. Is it bigger or smaller in the red blood cell? Smaller, right? It means water diffuses in or out? Water diffuses out. Very good. Okay, water diffuses out from the red blood cell. What term do we use to describe the red blood cell? Correct. The answer is crenation, right? We use crenation. So can you guys tell me, the solution here is hyper or hypotonic? It will be hypertonic, correct? Hypertonic, it will be hypertonic. Next, for solution, what? It has to be opposing. Water diffuses in or out from the red blood cell? Into the red blood cell. What term do we use to describe the red blood cell? What term do we use to describe the red blood cell? Hemolysis. Very good. We have to use the word hemolysis. Do you think the solution is hyper or hypotonic? All right, the solution is hypotonic. Right now, we have our answer. State the type of solution where solution X is a hypertonic solution. Solution Y is a hypotonic solution. Right, hypotonic. Give an example of solution X and Y. For solution X, okay, for solution X, can you give me any example that you know they are hypertonic solution? Any example? Yeah, hypertonic solution. Any percentage also can, guys. You can write maybe 5%, 10%, 15% of what? Solution. Salt solution, correct? You can write sucrose solution, whichever lah, guys. 5%, sucrose solution, salt solution, doesn't matter. As long as you have a percentage. Or you can say just a concentrated. Concentrated salt solution, concentrated sugar solution also can. Solution Y, how do we define it as a hypotonic solution? Any example? It has to be hypotonic solution. Any example? That has 100% water. Correct, distilled water. Very good. Distilled water. Distilled water. Explain the effect of solution X and Y to cell P and Q after being immersed for half an hour. The question is 4 marks, so you're going to have 2 marks over here and 2 marks over here, right? Based on the marks distribution, 2 and 2 marks, right? To write in cell P, because just now we wrote the term already, right? So we can skip the, so not term, we can skip the hypo, but we have to write the term. The term that we have to use here is crenation. So the first sentence that we write is red blood cell undergo crenation. Can you write RBC? Cannot. You're going to write red blood cell. The percentage doesn't matter, one, guys. You can write 10, 5, 7, 8, whichever your lucky number also can. The number doesn't matter as long as it's more than 1. Okay, second sentence, hypothesis already mentioned, so we can skip this sentence. We're going to write the third sentence, water molecule. So water molecule diffuses out from, if it's an animal cell, remember to use the word cytoplasmic. Diffuses out from cytoplasmic of red blood cell. By what process? If it's a water molecule, the process has to be osmosis. Very good, osmosis. Okay, let's write the last sentence. It's only a very short answer. Red blood cell shrinks. That's all. Okay, it's a very easy answering technique to use. Done. You can try to write Q by yourself. It's just opposite answer. You only have to change these few words. Yeah, these few words. Okay, the one I underline is the one that you're going to change lah. This one lah. Together lah. Okay. You can try to write it by yourself, guys. I will not read it out, but you can try to write it by yourself. The answer is given to you already. Just now we mentioned before. Oops. Try to write by yourself, yeah, guys. Don't just copy. Try to do it by yourself. Just change a few words. Definitely you can do it by yourself. Done? Let me know. I'll wait for another 5 more of you, okay? 1, 2, 3, 4. Very good. 5. Easy question, right? Use the same answering technique, okay? Explain why the process named in Y does not occur in plant cell. Why do you think that hemolysis does not occur in plant cell? Because plant cell has what? That it doesn't cause them to burst. Has a cell wall. Very good. So you're going to say plant cell has a cell wall. Plant cell do not burst because they have a cell wall. Because they have cell wall. If you want to explain some of the characteristics of cell wall, you can say cell wall that is strong and rigid. Strong and rigid. Rigid means strong. I mean, like it's another word to explain that they are strong. Rigid can only be used in plant cell wall. We don't use rigid in any other words, only in cell wall. Okay, a group student carry out an experiment to determine the percentage of red blood cell that undergoes hemolysis when immersed in different concentration of sodium chloride solution. The graph in 3.1 shows the result of experiment. Based on the graph, explain what happens to the red blood cell at R and S. Okay, if you look at this is the percentage of the red blood cell undergo hemolysis. This is the percentage of the sodium chloride solution. At 0%, this is literally 0% of salt solution. At 0% means it's very, very diluted. What happens to R? Hemolyze, right? It is what it says, right? Hemolyze, right? So at 100%, the red blood cell undergo hemolysis. At 0.85%, this 0.85 is half, right? What happens to the red blood cell at S? Do they undergo hemolysis? No, right? 0 over here, right? So it means what? As it remains unchanged. At 0.85, this is a isotonic solution. This is a hypotonic solution. Makes sense to you? This is isotonic. This is hypotonic. So they asked you to explain based on R and S. 6 marks, 3 marks for S, 3 marks for S, 3 marks for R and S, 3 each. Teacher, why lower concentration, more solute? What do you mean lower concentration, more solute? Lower concentration, it is 0%. 0% of solute means there's no solute inside. At 0%, it's just water. This is 0.85, right? This is 0%. Means at this point here is 100% water. There is no solute inside. So that's why it bursts. At 0%, it bursts. At 0.85%, it remains unchanged. And this is how the graph looks like. Can it be a negative graph? The answer is yes. It can also go down. Later, I'll show you a negative graph later on. So to explain R and S respectively, one by one, we're going to talk about R first. At R, 100% of red blood cell undergo hemolysis. Okay. Yes, in AC, anything that is more than 4 months is AC already, actually. Undergo hemolysis. Second sentence, you're going to talk about the hypo, right? So you're going to say, the red blood cell is immersed, because they didn't give you any percentage over here. You're going to say, is immersed into a hypotonic solution. Water diffuses into cytoplasmic of red blood cell by osmosis. Red blood cell expand and burst. It's the same answering technique. If you want to talk about isotonic solution, right? Isotonic solution, the red blood cell remains unchanged. There is no changes. So how do I mention that the water molecule diffuses in and out at the same rate? Just now I teach you a new word, right? Cytoplasmic is cytoplasm. It's to the cytoplasm of red blood cell. So when you compare about the solution with the red blood cell or plant cell, you have to write cell set. Cell set means vacuole. Cytoplasmic means cytoplasm. Okay, if it's isotonic, what are the words that I can use to explain the water molecule diffuses in and out at the same rate? It's no net movement of water, guys. Okay, correct? The answer is no net movement. It has to be no net, guys. Not net now, it's no net movement. So your answer for S, let's say at S, red blood cell remains unchanged. The solution is isotonic to cytoplasmic of red blood cell. No net movement of water occurs. No net movement of water occurs. No net movement of water occurs. Okay, done. Let me know, guys. We're gonna move to the next question. All in one paragraph. No, this is how you write an answer. What? 1, 2, 3, 4, 5, 6, 7. If you want to write in one paragraph, also can if you want to. It doesn't really matter a lot whether you want to write the paragraph or not. But writing in this way, writing in this way is easier for the teacher to know that you are writing. You can write this in exam as long as your answer is in a short sentence. Exam, no RBC, red blood cell. I'll wait for another 5 more of you, yeah? 1. Can bring correction tape into exam? Of course you can. Only SPM you cannot use only what? In normal school exam you can use. But again lah, it's depending on the teacher lah. But SPM you're not supposed to use correction tape. But school exam doesn't really matter. Okay? Okay. Now just now I say that there is a negative graph, right? Okay, what is a negative graph? Let me show you a negative graph. Let me flip to the question to show you what is a negative graph. Okay. Wait, this is a negative graph. Can you see? I mean, there's a page of negative graph. This is a negative graph. We have positive, means that gain in water remains the same, loses water. It will be like that. Something like that, okay? So this is a negative graph. It could be a negative graph lah. Teacher, are exam question like this, or they are more K-bar question? Actually, to me, you know what is K-bar question? To most of the students, what is a K-bar question to you? It's a question that you never see before. If a question that is very hard but you've seen before, it's no longer a K-bar question. So the thing is, when you do question, you have to do different type of question every time, not doing the same exact question. So when you see a lot of question and you know that, oh, this is how you answer it, because the answer will be the same. No matter whether they're easy question, K-bar question, the answers are the same. It's the same answer to every question. So you have to see a lot of questions, then only you will know that no matter what, it's still the same answer. So I believe that to you, K-bar question is a question that you never see before lah. If you see this question that's very hard, but you did it before in class, do you think it's still a K-bar to you? I don't think it's still a K-bar to you, right? So you just have to do a lot of questions. What does it mean if shows a negative graph? Negative graph means they loses water. Negative means they reduce in mass. When they reduce in mass, means that they loses water. It's hypertonic solution. So if it's a negative graph, usually when you have to draw graph, right, it will be in paper 3. Because you have to measure your potato strips in a gram. So that's why you have the negative graph. So when you do paper 3 in exam, if you see a negative graph, it's normal because you loses water from the plant cell. Positive means you gain water. Negative means you loses water. Okay, now question 7 is a plant cell. Again, 2.1 shows the condition of plant cell before treatment. 2.1b and 2.1c shows the condition of plant cell after it has been immersed in solution P and Q respectively. Name solution P and Q. Based on this diagram, P is the normal one. Okay, 2.1. Do you notice that the vacuole becomes bigger in size? If they are bigger in size, what term do we use to describe the cell? What term do we use to describe the cell if they are becoming bigger in size? The term will be turgid. Very good. The term is turgid. So can you guys tell me solution P is hyper or hypotonic? Solution P is very good, hypotonic. Then you will know solution Q, right? It's opposite. Solution Q has to be hypertonic. But what term do we use to describe the plant cell? Correct. It's called plasmolysis. Plasmolysis. Because the plant loses water, it's called plasmolysis. So the solution P, this is a hypotonic solution. And then Q will be hypertonic solution. Hypertonic solution. State the condition of plant cell after it has been immersed in solution P and Q. The term that we have, this is turgid. This is plasmolyzed. Easy question. Explain the process that has caused the condition to be in cell in 2.1c. C is plasmolysis. Usually, if you want to explain your answer, we will not choose to repeat whatever that we have written over here. We can try to write the other 2 sentences because we have term, right? Term already has it. We have hypo, but we still have what? We still have water molecule and the explanation, right? So you can choose to write the other answer. But if you want to write the same answer again, I mean, it's not wrong, but choose to write another answer. So in this situation, the plant loses water or gain water. If they have plasmolysis, the plant diffuses out or diffuses in? Which one? Diffuses out, correct? It diffuses out, right? So your first sentence, water molecule diffuses out from plant cell. You have to use the word cell sap. Cell sap is vacuolar. Cell sap of plant cell by osmosis. Next, we can explain our answer. The vacuole strings become smaller, right, from the diagram. Next sentence is your plasma membrane. Do you think plasma membrane push against or pull away from cell wall? Plasma membrane push against or pull away from cell wall? All right, pull away, because from the diagram you can see they pull away, right? Pull away from Cell wall. Plasma membrane pull away from cell wall. So if you notice that we are actually repeating the same answering technique for all questions, no matter whether they are plant cell, red blood cell, master green cell, it's still the same answering technique. Done? Let me know. Are we for 5 of you? Yeah. 1, 2, 3, 3. 3, 3, 4, 5. Okay. Next question. 2.2 shows a palisade mesophil cell after being immersed in distilled water for a certain period of time. Keyword here is distilled water. Is distilled water hyper or hypotonic? Very good. Hypotonic. Water diffuses in or water diffuses out? Water diffuses in. Correct. What term do we use to describe the plant cell? Turgid. Very good. Turgid. So we have your answer. Let's form sentence right now. First, we're going to start from the term. Term is turgid, right? So you're going to say plant cell becomes turgid. Plant cell becomes turgid. Second sentence, we're going to say hypo. Distilled water is hypotonic to cell sap of plant cell by osmosis. Next sentence, water molecule diffuses into cell sap. Sorry, not here. Sorry, I wrote wrongly just now. Of distilled water into cell sap of plant cell by osmosis. Next, vacuole expand. But if you don't want to write the third sentence or fourth sentence on, right now, mind one, guys, because three marks, the first 3 sentences is already done. Do you recommend memorizing answering keyword for exam? If you can, that will be the best. If you want to write plasma membrane push against cell wall, also can. Okay, let me finish that. Only 1 sentence left. And plasma membrane push against cell wall. Push against the cell wall. Okay, in E1, a housewife has immersed the mustard green that she bought from the market into a water to make it fresher. Explain why. Water here. Is it hyper or hypotonic? Water, of course, this is a hypotonic, right? So the answer is the same, guys. It's the same answer. 2 marks, 2 sentences. You're going to say a water molecule, or you can say just water. Water is hypotonic to cell sap of mustard green. Mustard green is just vegetable, guys. Water diffuses into cell sap of mustard green by osmosis. Easy question. Not curved outward. Mustard green is a normal vegetables. Any vegetables is mustard green. I added this mix the mustard green turgid. Or can you write becomes turgid? You can say the mustard green becomes turgid also can. Because it's hypotonic. Next, they ask you to draw the diagram. They ask you to draw this diagram. How do you want to draw a cell that is turgid? First, the outline for you, right? Don't have to draw the outline. Just draw the vacuole. The vacuole has to be very big, very good. Big vacuole. Nucleus dot is the cytoplasm. This is how you're supposed to draw a plant cell. Very big black hole. Done with this page? Done, let me know. We're going to move to the next page. Okay, next question. Diagram 3 shows the observation. Yes, it's turgid. It becomes turgid again. Diagram 3 shows the observation of a potted plant on first and fourth day. Brahma forgot to water the plant for 3 days. The condition of the plant changes from S to T. Based on diagram, explain what had happened to the plant on the fourth day. So the first day, it was very healthy plant. And then 3 days forgot to water the plant. What happened to the plant over here? The plant wilt, right? Forgot, there's no water inside, right? So this plant here undergo what process? They undergo loses water, right? Loses water means what? Plasmolysis, the solution is hypertonic right now. So you're going to say first sentence, the plant wilt. The plant wilt as the soil is hypertonic to cell sap of root hair cell. Next, you're going to say water molecule diffuses out from cell sap of plant cell by osmosis. Then you're going to say vacuole strings and plasma membrane pull away from cell wall. One more sentence. Let me write at the bottom now, guys. So you're going to say the plant cell undergo plasmolysis. It's under the same answer, yeah, guys. Does it mean that the soil will suck out the water? Yeah, the soil will take the water. The water will diffuse into the soil. So the plant will cause of the soil, not because it drinks the water already. Huh? What do you mean? The plant will is because that the water diffuses out from the water. The plant will is because that the water diffuses out from the plant. The plant will because the plant loses water. Okay, next they ask you, explain how the condition of a plant can change from T to S again. So you right now, as a person, how would you want to save your plant? Your plant is undergoing plasmolysis process. How would you want to save a plant right now? Your plant is at T right now. How do you want to go back to S? Correct, you water the plant. Easiest way, you water the plant. So the plant undergo what process? A reverse process is called what? The reverse process is called deplasmolysis. Very good. So you're going to say first, you water the plant. Pour water into the soil of the plant. The plant cell undergo deplasmolysis. Water diffuses into cell sap of plant cell by osmosis. The plant cell becomes turgid again and vacuole expand. Can we mention distilled water? As a normal human, let's say for me, right? If it's a normal human, right, we cannot get distilled water. We can only put water. Your tap water is not distilled water. Distilled water you don't buy. So you don't write distilled water, just put water will do so. Because you have to assume that this person is a normal person, like a normal citizen, right? Normal student. As a normal people, we don't get distilled water. Okay, done? Can cook? What do you mean can cook? Can boil? Boil water. Boil water also can, as long as they are water. But usually we will just use tap water because tap water has mineral. Free mineral to the plant. Okay, draw a label diagram to show us the condition in F1. How do you draw F1? Means the plant is undergo plasmolysis, right? The plant is dying, right? So first, to draw a plant cell, remember to start from a cell wall. One more layer over here. And then plasma membrane, you're going to pull out from the cell wall. The vacuole has to be smaller. Nucleus, ... Remember, this is a label diagram. You have to label the diagram, guys. No label, losing one mark. Cell wall, plasma membrane, nucleus. Oh no. Nucleus, vacuole, cytoplasm. Only have to label 5 things. Don't have to draw the rest of it. Only these 5 things. Cell wall, plasma membrane, vacuole, cytoplasm, nucleus. Remember, correct plasma membrane, not cell membrane. It's a plasma membrane. So since we have did quite a few questions today, you will notice that all questions, remember to use the same answering technique. No matter whether they are plant cell, red blood cell, even mustard green cell, use the same answering technique. Use the same sentence for all questions. Use it in 3.3 and 3.4 subtopic. Okay, so today we will end here. Hopefully that you learned something today. Hopefully that you can score well in your exam. Any question you don't understand, you can ask me now. If it's not, then I will see you guys again. For my student, I will see you guys in class, okay? Okay, bye-bye. The rest of you have no question. Bye-bye, bye-bye, bye-bye.